Hello dear participants, I welcome you all in this certificate course on data interpretation using MS Excel and SPSS. We are starting our lecture number 4 of module 1. But before starting this lecture, let me put forward few questions for you. Questions are as follows. What is statistics? Why do we use statistical techniques in research? What are the different types of statistical techniques? Can we apply any statistical method on any type of data? And the last question, which is very important, how to begin with or how to start with analyzing the data. So to answer all these questions, we all are here in lecture 4. Title of lecture 4 is Introduction to Statistical Techniques. Objective of this lecture is to make you familiar with the statistical techniques or methods which actually we use during our research for the purpose of data analysis. So this part we all are already familiar with. This part already we have seen in the previous lecture. Data is classified into two parts, qualitative data and quantitative data. Moreover, we have already seen that there are four measurement of scale: nominal scale, ordinal scale, interval scale and ratio scale. Nominal and ordinal scale are associated with qualitative type of data, and interval and ratio scale are associated with quantitative type of data. We have seen this part also that in SPSS we are going to consider only three different scales: nominal, ordinal and scale. Here this scale includes interval scale and ratio scale, and this scale is actually associated with quantitative type of data. So it was kind of revision to all of you. Now at the beginning of this lecture we'll go with the definition of statistics. What is statistics? Statistics is concerned with scientific methods for collecting, organizing, summarizing, presenting and analyzing data. These statistical methods also help us to draw valid conclusion, and these methods also help us to make reasonable decisions. In this lecture, we are going to see classification of these statistical methods and the meaning of each category. This classification is actually, it is a broad classification within which there will be different statistical methods that we are going to see in the upcoming slides. Now let me come back here to the functions or the important features of the statistical methods. What are the functions? What are the features of statistical method? Statistical methods help us in the collection of data. These methods help us in organizing our data. These methods help us summarizing our data. They help us in presentation of our data. They help us in analyzing our data, and they help us to draw fruitful conclusions. So it was all about the meaning and functions or the features of statistical methods. Let me take you all to the classification of statistical techniques. Statistical techniques are broadly classified into four parts. First is descriptive statistics, inferential statistics, third is associative, and fourth is predictive statistics. In few books, associative statistics and predictive statistics have been considered as a part of inferential statistics, but to make it better understanding, we have classified it into four parts: descriptive, inferential, associative and predictive. In each of this classification, there are different statistical methods involved in, and we are going to use all these different methods. Using all these statistical methods, we give statistical treatment on our data, and we get some results. So this course will be dealing with all these statistical methods. This course will be explaining you the process using which we are going to find out results, and finally that how can we give meaning to these results, the interpretation part. So this course will deal with all this part. But so far this lecture is concerned, we are just in this lecture we are just going to understand the meaning of descriptive and what type of statistical methods are involved in this. Then the meaning of this, again the statistical methods involved in inferential statistics, meaning of this and the statistical methods involved in these both. Fine. So let me start with first classification, that is descriptive statistics. What is descriptive statistics? Descriptive statistics are tabular, graphical and numerical methods used to summarize data. So three parts are involved here: tabulation, graphs and numerical methods. Fine. And they all are used to summarize the data. What is data summarization? Data summarization is the process of describing data by computing a small number of measures that characterize the data set. This definition of data summarization is actually associated with numerical methods only. Fine. What are the functions or the features of descriptive statistics? Descriptive statistics typically used early in the analysis process. So suppose if I am having data with me, then I should first go with the descriptive statistics. I should go with descriptive statistics first. And why so? Reasons are mentioned here in point number 2 and 3. We should go with descriptive statistics first because it will help us to understand the nature of our data and it reveals the general pattern of our data or the responses. And then we can decide that on the basis of this we can go for the subsequent analysis. So this is the base. It also helps us to reduce the data. So these are the functions or the features of descriptive statistics. Now let me take you to the slide where we have mentioned what are the different statistical methods involved in descriptive statistics. They are here. First is a tabular analysis, other is a graphical analysis, and third is a numerical analysis or methods. In descriptive statistics, in tabular analysis, frequency table is involved, cross table is involved, stem and leaf table is involved, and there are a few more. In graphical analysis, bar charts, pie charts, histogram and polygon are involved. So far numerical methods are concerned, measures of central tendency is involved, in which again arithmetic mean, median, mode, there are few more. Dispersion is involved, range, quartile deviation, mean deviation, standard deviation. Movement, skewness and kurtosis is also involved in descriptive statistics. Fine. But now the question comes, if we know all these methods of the descriptive statistics, can I apply any descriptive technique on any type of the data? As you all know that there are two types of the data, qualitative and quantitative. Can we apply any descriptive technique to anyone? Answer is no. Answer is no. And here is the classification. We are having different descriptive statistical techniques with us, but if your data is qualitative, you can only go with frequency table or cross table. So far the tabular analysis is concerned. You can go with only bar charts, pie charts and donuts. So far the graphical analysis is concerned. And you can only go with a percentage, mode or a median. So far the qualitative data or the qualitative variable is concerned. On the opposite side, if you are having quantitative data, then you will be going with stem and leaf display. So far the tabular analysis is concerned. You will be going with histogram and polygon. So far the graphical analysis is concerned. And you will be going with mean, median, mode and plenty of statistical methods are there. So far your quantitative data is concerned. So here is the difference between which method that we can use for the different type of data. We cannot use mean here for the qualitative data. Why it is so? This question will be answered in the separate lecture where we'll actually give descriptive treatment on our data. In a separate lecture, we'll see that why it doesn't means it is not a valid standard. Where we go wrong, that we'll see in the that separate lecture, where in actual we'll give statistical treatment using MS Excel and SPSS. Fine. Objective of this lecture is to just make you familiar with the classification of statistical techniques and the methods involved in each. Fine. So here the thing is that first you will have to identify the type of data first, and then you will have to decide that which descriptive technique that actually you can apply to that respective data. Fine. Now we'll shift to the second classification, that is inferential statistics. What is inferential statistics? Inferential statistics are used to generate conclusions about populations characteristics based on sample data. So it works on the sample data. What are the important functions or the features of this statistics? First is, typically it is used after descriptive statistics. So we starts with the descriptive statistics. Once we used descriptive statistics, we become familiar with the pattern of data we have, and then we go for the inferential statistics. It works on sample data. It helps us to make inference for population, and it helps us to draw conclusions about population. So these are the important features of the inferential statistics. Now, what are the different statistical methods involved in inferential statistics? They are as follows. Inferential statistics, actually it is associated with hypothesis testing. Now what is the meaning of hypothesis? How to make statement for hypothesis and how to test it. All this part we are going to cover in the respective lecture, when in actual we'll be treating inferential statistic, when we'll be treating inferential statistics on our data. In that respective lecture, we'll see the meaning and how can we make the statement and how to test all these things. In this slide, just my objective is to highlight you or to enlist the different hypothesis testings which are the part of the inferential statistics. They are as follows: one sample t-test, independent sample t-test, paired sample t-test, ANOVA is there, ANOCOVA is there, chi-square test is there, Wilcoxon rank test is there, Mann-Whitney test is there, and Spearman's rank correlation is there. There are a few more. Fine. But again, question comes that can we apply all these tests on any data? Answer is no. You will have first you will have to identify what type of data that you have, and then you can choose appropriate hypothesis testing. Now here is the classification again. Here is a qualitative data on the left hand side, and on the right hand side there is a quantitative data. If you are having a qualitative variable on which you wish to make hypothesis test statement, or for which you wish to test the hypothesis, then you will have to choose chi-square test or Wilcoxon rank test or Mann-Whitney U-test, Spearman rank correlation, or Kruskal-Wallis test. Fine. If you are having quantitative variables of your interest, and if you have made a hypothesis statement considering those numerical variables, then you can go with one sample t-test or independent sample t-test or pair sample t-test, ANOVA, two-way, one-way kind of. Fine. So the thing is, if you know your data, then and then only you can go forward for statistical treatment. So here are some important note. First, you will have to understand the meaning of respective test. You should know what is one sample t-test, two sample t-test, chi-square test. You should know the meaning of that thing, and that meaning we are going to see in the respective lecture. Each hypothesis test has its own prerequisite. Each hypothesis testing, chi-square, one-way, or ANOVA, or two-way ANOVA, one sample t-test, or pair sample t-test. Each hypothesis test needs something. It needs some kind of prerequisites in the variable. So the first thing comes here, that you should have to identify those prerequisites in your data or invariable. Whether those prerequisites are there in your data, that you will have to identify first, and then you should go for the respective test. Fine. So these are some points, and these parts means this part we are going to revise in the hypothesis testing, that lecture. Fine. Now let me take you to the further slide. We'll move on to the third classification, that is associative statistics. Associative statistics determines the strength and direction of relationship or association between two or more variables. Suppose there are two variables, like say that rainfall, rain, and other is say that agricultural production. Now I'm having data of, suppose say that 50 years, and I'm comparing both the data, and then I'm saying that how much they are associated. Are they positively associated or are they negatively associated? And if they are associated, how strong they are associated? Fine. So to answer all such kind of questions, which we usually go to the associative statistics. What are the functions or what are the features of associative statistics? It represents the existence of association, but it never talks on the cause and effect. Fine. Cause and effect been answered in regression or in predictive statistics. Associative statistics only speaks on the existence of association. Fine. It determines the pattern of association, whether it is positive or negative kind of thing. Right. It explains the degree of association, whether they are strongly associated or weakly associated, kind of things been explained in associative statistics. It is useful for subsequent analysis of predictive analysis. So this is the base for the predictive statistics, which the meaning of which we are going to see soon in upcoming slides. Now let me take you to the further slide, in which we have mentioned few statistical methods involved in associative statistical technique. So they are like, first one is the graphical, that is scatter diagram, then cross tabulation is there, correlation coefficient is there, and Spearman's rank correlation is also there. Again the question comes, can I apply all this on any type of data? Answer is no. Again you will have to go back to the base. And what is base? First you should have to identify what type of data you have. If I'm having qualitative data, I'll go for cross tabulation and Spearman's rank correlation. If I'm having quantitative data, I'll go for scatter diagram, correlation coefficient, and partial and multiple correlation. Fine. So it was all about associative techniques. What is predictive statistics? This is last part of the classification of statistical techniques. Predictive statistics help us to make a forecast of a dependent variables based on independent variables. And if you remember, in the lecture of introduction to variables and data, we have already seen the meaning of dependent variable and independent variable. Fine. What are the functions or the features of predictive statistics? It estimates the value of dependent variable from the value of independent variable. Next feature is it measures the error involved. What is the meaning of error? That again we are going to understand in a separate lecture, when we'll be treating our data with the predictive statistical techniques using MS Excel and SPSS. In that lecture we'll explain what actually do we mean by the error thing. Fine. Then it determines the cause and effect, and this part was absent in the associative statistics. So in the predictive statistics we can determine the cause and the effect. Fine. And the last is forecasting. Fine. Now let me take you to the slide where I have mentioned different statistical methods involved in predictive statistics. So predictive statistics is actually associated with the regression models, and there are different regression models, like linear model is there, log model, lean log model, log lean model, reciprocal model, mixed model, or quadratic model, and there are many. Fine. But again, can we apply all these models on any data? No. First, you will have to identify your type of data. So let me take you to the further slide. If you are having qualitative data, you can go with a dummy variable model. But for this model, again, there are some prerequisites. There is some design. Fine. Your data should have those characteristics. Then only you can go with a dummy variable model. Fine. And so far the numerical data is concerned, there are plenty of regression models, plenty of models that you can apply on the quantitative data. Fine. Now let me take you to the further slide. How to begin with working on data? Suppose I am having data with me. Suppose I am having some set of data, and how should I start? First thing comes first, you should first start with the tables. What kind of tables? Frequency table or the cross table or stem and leaf, depending upon the type of data or type of variable you have. Once you are having tables, then go to graphs. Then there are different types of the graphs like scatter diagram or the columns or bar. There are many. After this, you can go for the numerical methods of the descriptive, inferential, associative, and predictive. Right. So this is the way that we should go when we are giving statistical treatment to our data. Fine. Now let me take you to the further slide. So this is the classification of statistical techniques, broad classification: descriptive, inferential, associative, and predictive. Furthermore, again in each, we have to be very careful when we are using descriptive techniques. We should be very careful that for a categorical data there are different techniques, and for numerical data there are some different techniques, and the story is same for all others. In inferential, in associative, and in predictive, you should be very careful with your data. First, you should identify what type of data that you have, what type of variables actually you want to treat with statistical techniques, and then you should choose appropriate statistical technique. Fine. Then and then only you are going to get good results, or then and then only you will be able to give some meaning to those results. Now let me take you to the summary slide. So here is the summary of this lecture. Here are the statistical techniques: descriptive technique or inferential statistics, associative and predictive statistics. Here are the measurement of scale: nominal and ordinal. They both comes in the qualitative type of data, and scale, it comes in quantitative data or numerical data. Correct. Now, so far the nominal data is concerned, measurement scale is concerned. So far the nominal measurement scale is concerned, you can use only percentage and mode in descriptive. You can use only chi-square from inferential, cross table from associative, and dummy variable that you can use from the nominal data in predictive statistics. So far the ordinal is concerned, again percentage you can use, median and mode in descriptive. In inferential, Friedman, ANOVA, Wilcoxon rank test you can use. In associative, you can use only rank order correlation, and there is nothing here in the predictive. So far the scale data is concerned, you can use plenty of statistical methods. So far inferential is concerned, there are many statistical techniques which you can apply on scale data, and in associative you can go with scatter diagram and correlation coefficient, and there are plenty of regression models which you can apply on the scale data in predictive statistics. Fine. Now same thing if I explain with the help of type of data. So here are two types: qualitative data and quantitative data, and you can observe for qualitative data there are very less statistical techniques available to apply on. You go to descriptive, you go to inferential or associative or predictive, you will find that categorical or qualitative data, we are having some limitations to apply statistics. But if you'll come to the quantitative or the numerical type of variable or data, there are plenty of statistical techniques which we can use on this data, and we can get a very meaningful results out of it. Fine. Now let me take you to the concluding part of this lecture. So data classified into two parts, qualitative, quantitative, and this thing already we have seen at the beginning of this lecture. There are four measurement of the scale, and you can see that less use of statistics on this part. As we go down, more use of statistics is possible. Fine. And the same thing is explained with these three categories which we consider in SPSS. So there is less use of statistics on nominal, little more on ordinal, and huge statistics that we can use on the scale data. And here is the last slide. These are few questions which we have asked at the beginning of this lecture. And what were these questions? The questions were like, what is statistics? Why do we use statistical technique? What are the different types of statistical techniques? Can we apply all the statistical techniques on any type of data? And finally, how to start with analyzing the data. I hope this lecture has answered all these questions, and you all have understood this. You all have understood this lecture. You all have enjoyed this lecture. And here we'll stop, and we'll meet you again in the next lecture. Thank you. Thank you for your kind listening.